You're muted, Wayne, if you're talking.
Hello, audience or room. Can you hear us? We
can't
don't hear
hear
anything
anything.
online.
No. We don't have sound in the Zoom chat.
Unfortunate.
I'm sorry that I was muted. But I hopefully am not muted now. Okay. So let's see, where was I? Okay, so this is an example of a GitOps repository. This is one of our development clusters, right? So you can see that basically this is a Git repository. These are directories. You know, there's a directory for each namespace. Within the namespace, you know, this is conventional. It doesn't really matter how the tree is organized, but within, like say this dev namespace, we have a folder called charts where we have a chart for copy. So that's a Helm chart that Flux will manage for me. We have a folder here for some edge modules. We have a folder for FOLIO modules, and we have these modules defined in that. We have some secrets defined as Kubernetes secrets. You know, it's basically like everything, right? This is a sort of a layout of my cluster. By namespace, controlled as files and Git, and that's all. Yeah, you know, they're just Kubernetes manifests, right? So it's very straightforward to keep track of. So the magic that kind of makes that happen, what Flux is this special kind of application that runs on a Kubernetes cluster that's kind of operated. This is from the Kubernetes documentation, a definition of what a Kubernetes operator is. So, I mean, I'm not going to read it, but the basic notion is that an operator is a piece of software with domain knowledge about the kind of application that you're trying to manage that does the things that a human operator would do, right? So if you wrote a ticket for your operations department to say, to say that Gießen now needs the Mod OA app installed, right? You would hand it to your operations staff and they would do a bunch of things. And that's what this operator is attempting to be, is that sort of like equivalent of a human operator that acts as this actually is important, so I'm going to read it. It's a client of the Kubernetes API, right? So it watches Kubernetes and can pull to find out when resources change. This is really, it's a piece of code that extends Kubernetes without needing to change Kubernetes, right? It's one of the most powerful things about the Kubernetes architecture, that you can do this write this kind of code that actually manages resources in your cluster. You can extend the API with custom resources, which is pretty amazing. So this is from the operator white paper. This is sort of what it is supposed to look like, right? So you have this declarative. I want mod OA to be deployed for Gießen. I want Gießen to be using mod OA. And the software, the operator, is watching for those changes. And then it will apply changes and maintain the managed resources as required. And then it will report its current status so that you can find out what it did or didn't do, and what the state of things is. And that the state, of course, allows you to do things in order, right? So you can keep track of what states of various operations. So this has been kind of spinning around in my head for a year or so. And in June this year, I had the opportunity to come and join the German operations, the DevOps community in Frankfurt. And I presented this slide to them. I said, I have this idea.
Were they happy?
They were remarkably happy. Actually, that's a great question. No, because I wasn't the only one who'd been thinking about it. it turned out. I was not the only one been thinking about it, and there were lots of ideas in the room about, like, what might that look like, and how would we make that happen? And so, right, so out of that meeting came this sort of notion of a project to build a folio operator for Kubernetes, which is what we're engaged on right now. Yeah, so we did decide that these things are just kind of out of scope. We said, you know, we're not going to try and provision OCopy, we're not going to try and provision Eureka, we're not going to try and provision Kafka, all of these things. Those are infrastructure. It's out of scope for the operator. So it's not that these things aren't important, and perhaps there are ways that you might want to do it, but, you know, for example, many consortia in Europe would never use S3 for storage, right? Whereas many of us in the US are very comfortable using S3, and it's very easy. So why would, you know, this operator should not be managing MinIO, right? Because that's not really, that's sort of out of scope for the domain. Similarly, you know, as we've heard a lot this week, you know, there are going to be multiple sort of base platforms for Folio for the next year, probably. And so, you know, what platform is underneath is out of scope. Like, it's not up to this operator to say, this is going to be a copy, or this is going to be Eureka, and this can only work with a copy or Eureka or whatever. It's like very important that remain open. Same with all the other things, right? Like, people have different ways that they want to manage Kafka, database management, so on, out of scope for this operation. So my initial title for this talk was "So Let It Be Written, So Let It Be Done," which is a quote from the Ten Commandments. It's a line spoken by Yul Brynner as the Pharaoh of Egypt. But that was too long a time. So anyway, the initial proof of concept is okay, if we have the required infrastructure that we talked about, can we build a Quesnellia folio tenant just by defining resources in a Kubernetes cluster and have the operator do the things that need to happen to make that tenant come up and run? So, I mean, that's a neat idea. So how do we get there from where we are right now, which is a big question mark on the slide, right? So the first thing is, for a proof of concept anyway, there's a piece of software out there called the Operator SDK, which has, which you can use with Go, with Ansible, and I think with Python. To code. And what it does is it helps you sort of, it sort of does a lot of the mechanics of the things that need to happen for operator creation, for creating an operator. So using that piece of software, we need to create custom resource definitions for we have to figure out, okay, so we know what we want. We want to deploy mod OA, for this tenant, or we want to stand up Quesnellia. So what are the resources that are required to sort of define that state, right? Like, what are the things that we need to, what would be the things that we need to declare in order for that to be a sensible operation? And then, you know, for a proof of concept, again, I think rewriting in Go will probably be something that happens at some point. But for now, just write Ansible roles and playbooks that reconcile the cluster to the desired state. And then, you know, just show that we can do it, right? Deploy a tenant to the cluster by creating custom resources. So we haven't done all these things. This is a roadmap, right? So I proposed a desired state with 4 different resource types. And, you know, there is kind of a reason that these things sound familiar. So we talked about it in Hamburg. Mike gave a talk about folio modularity and proposed a file format for defining what at the time we called FAM files, applications, really, that would bundle together areas of functionality in folio. And then, the following year, Vince and Craig, I think really building on a lot of the notions that Mike presented, talked about folio platforms. And then they went and did it, right? I mean, they kind of went and did it, and that's cool. So, these resource types are not, these aren't, sort of original with me by any stretch of the imagination. So the first notion that I thought we would need to describe is what is a platform. And that in some way that's because it's the highest level, it's the most simple. The notion would be that a platform is a group of applications that work, that the provider, the person deploying Folio, say work together. And you could define platforms that are that's a cluster-wide scope, right? Because you might have multiple namespaces that run Folio within your cluster. The platform definition should be common to them all. So I know if I'm running, you might think of a platform today as a Flower release. You might not, right? Like you might think of it as more composable than that. But today, probably the closest thing we have to it is a Flower release. So I would have a platform that defines, Quesnelia, general availability, and I would have another platform that defines Quesnelia CSP1, and I could have, so I could have these platform definitions that can be used by different tenants in different parts of the cluster, different namespaces within the cluster. Application. This is really meant to be analogous to the Eureka application or the FAM that was defined a couple of years ago, being a set of specific versions of Folio modules that together create a unit of functionality. And again, that's cluster-wide, so you can define, the notion would be to define these applications, you can pull them into different platforms, it's all something that can be used by any of your environments. And then this is sort of this is the piece that has no analog in Eureka. This is the environment, which I'm defining as, so this is, I'm going to read this one. It's the context for the set of services deployed in a Kubernetes cluster that use common infrastructure elements. Okay, so the notion would be, it doesn't necessarily have to be, there could be more than one environment in a namespace, but one environment, one Eureka, one environment, one Okapi, one environment, one module database, or multiple module databases. That's a little bit squishier, but things that, one environment, one Kafka, for example. So it's what we would typically think of as a Folio installation, is an environment. So it's the set of all those things that use the same infrastructure. And then tenant is a tenant in the environment. So these are some of the use cases that we came up with in June. We talked about them a little bit actually again last week, which was kind of fun. Some examples of what would be use cases for this. So it would be something like, I want to deploy the modules for a Folio release by creating a platform and associated application resources, and then creating an environment resource that includes the platform. I want to create a Folio tenant and enable, or I guess entitle is the new word, a Folio release for that tenant by creating a tenant resource that's linked to a particular platform and environment. I want to upgrade between Folio releases by creating a new platform and including it in an environment and linking it to a tenant. This is sort of the basic set of operations that are sort of the proof of concept, minimum viable thing that we're trying to accomplish. And in order to do that, we have to define these resource types. So I was going to look at my clock. Let's see. All right. I might have time to walk through this a little bit. This is an example of what's called a custom resource definition in Kubernetes. And it's a little easier to read here. And all it is, what it is so this is a part of the Kubernetes API, right? So it's part of the Kubernetes API. It's a resource that is in Kubernetes, and you load it into your cluster, and then it becomes available as a resource type that you can create manifests for, right? So it's versioned, right? In this case, the alpha one, you give it a group and all that stuff. It's versioned as the alpha one, and then the schema itself is an OpenAPI version 3 schema, which is really convenient. It allows for some linting, for example, and it also allows for, it's pretty human readable, but you can also generate some more human readable things from it, which is convenient for documentation. Getting down to the spec part here, these are then the things that I proposed in my first draft as the things that I would need to declare in order to have an environment built. So, that's the spec area is here. And so you can see there's a properties property. and so I defined some things that seem to me to be, critical for declaring an environment. So the first was the proxy type. The second is the proxy URL. Third, then are a set of secrets that can be loaded. So for example, you could use this to load database secrets into the environment, inject database secrets into the environment of a module that requires database secrets. And then let's see, what else did I talk about? The platforms that are to be deployed in the environment. And that's an array because you can have multiple platforms deployed in one environment. And then the platform has module settings. So this would be something that you could use to define an array of module specific settings for a platform. So you could say, in this environment, mod orders needs 3 gig of RAM because we have someone who's has a large set of, one of our tenants has a large set of orders and they just need more RAM for mod orders. Otherwise, the default would be to use the values that are defined in the module descriptor. Replicas, deployment type. I mean, there are various sets of things that are sort of what you would expect. You can override environment variables. You can override the container CMD, command, and so on. So that's the basic notion of what a custom resource would look like.
Right, you have an example one.
No, I don't. I do have I have the schema, but I don't have an example resource here. But basically what a custom resource would look like is it would look a lot like this, right? Because it's just a Kubernetes manifest. The API would be the API of the custom resource itself, and then the spec would contain all of the properties that were defined in the custom resource definition. We've talked a little bit about basic functionality. We had some advanced use cases or wish list things that we wanted to think about. These are some of them. I'm sure people can think of other ones. One would be like building a UI bundle and deploying it on an Nginx container. some way to manage that staging and prod so we can do promotion for changes between environments. Some way maybe to clone tenants between environments. That's a little trickier because a lot of that is on the database level. So I don't know how we would make that work. It might be convenient to do user permission management. Eureka might make that a little easier. That's to be seen. Be nice to manage reference data, right? And a lot of our reference data is in English. That's inconvenient for many of our international users. A last one that occurs to me, of course, is that there could be a way to share platforms and application definitions, declarations, between hosting providers and institutions. So that you have like all the settings that someone else used and you can look at them and use it yourself. So what's next for this project is we need to complete a first draft of the operator skeleton. We're going to publish it to GitHub, and we'll put it up on Docker Hub as well, right? Because you actually need the code as a container to deploy it to your cluster. I mean, you don't need it, but it would be a nice convenience, wouldn't it? And then when we get to that point where we sort of have something that we think might be working, we need to decide on kind of some next steps on how we would work with the sysops community and FOLIO to sort of formalize the project management. Would we want to create a project team, have a PO? Do we want to move this into the FOLIO space? Right now it's in the index data space, and it will be public, and it's on Apache 2, and it's part of the FOLIO portfolio, but there's no reason that it has to be in the FOLIO organization. Would we create a Jira project? So on, this kind of thing. And then of course, we need to see if this is useful by having various hosting vendors actually try to use it, right? I mean, certainly, so as someone who works for a hosting vendor, this is very much trying to solve problems that I have, right? So, we certainly intend to use this. So it would be interesting if it was picked up by other people in the community. And that is it. So my hope was that I would just sort of raise some notions, some thoughts in other people around what kind of feature set they would be interested in seeing, what are the boundaries of that feature set, what are some of the limitations of this approach, how might it be problematic in their environment, because I only know my environment really very well. And so I'm happy to open it up for questions and discussion. Thank you very much. All right.
Well, I've got one.
All right, go, Jay.
All right, so I'm just curious why you went with operators versus Helm charts, or maybe not a combo of both, right? Like a FOLIO Helm chart for a platform, whatever. Then here's my operator that runs all of the day-to-day life cycle, tenant management, whatever.
So that's a really good question. So I mean, there are a couple of reasons. The first is that I'm not really an expert in Helm, so I'm not going to comment on its, whether it has limitations or not. To me, it feels like this is more intuitive. This is the way I think about FOLIO. And so that model maps well onto this pattern. Whereas a Helm chart is more like, to me, a Helm chart is a lot more like sort of the FOLIO Ansible imperative approach, where you've got a bunch of variables that you have to define, particularly for something like a FOLIO environment, which is pretty complex. So you have sort of a bunch of variables that you have to define in one file, maybe even, and and then you have to, and then the Helm chart has the wisdom to interpret it and stand up the thing that you want. So I just felt, I think that was my thinking on it. I don't know, Florian, you had also worked with Helm charts for FOLIO, and we're thinking about moving towards an operator. I didn't know if you had any thoughts to add to that. I think Florian is.
Can you hear me? Can you hear me?
Oh, I do not hear you.
Yes.
Oh dear. Let's see.
You might be able to change the speaker output to your HDMI.
Well, I changed it to the USB-C. I was not able to change it to HDMI.
Well, it might still be picking up the speaker.
All right. Well, let me do this.
Can you hear me?
Florian, can you speak again?
Yeah, I try. Can you hear me now?
It is coming out of here. It's coming out of here. Is there a volume control on that?
Well, let me see if.
Or do I have a volume control on that?
Right, does anyone in the room know anything about computers?
You can you hear me now? No.
Oh, look at that. There's a plus button. Can you try again, Florian?
Can you hear me now?
Oh, much better.
Well, that's mine is off.
Yes. No, please go ahead, Florian.
You can hear me? Okay.
Yeah.
So with Helm charts, you can do many things, and you maybe can do everything an operator could do, but it's a little bit clumsy. You have to use jobs and start containers that run jobs like registering modules to Okapi or doing something else, and you have to take care that some jobs only run on initial install, some jobs on updates, some jobs if you delete something. That's not very easy to direct Helm to do the right thing. So we think that the operator is way more flexible because operator has much more knowledge on the state before and the desired state, and then he can much easier determine which changes have to be done and let the operator do this.
Yeah, I think that's a really good point. I'm just brought back up the slide that talks about the sort of basic flow of how an operator works. And an extremely important piece of that is the status, right? And you have the opportunity to get much richer sort of status out of an operator than you can out of a set of jobs that run.
Yeah. You can do many things with Helm too. You can query the status with Helm too, but you're limited in Helm to the Helm templating language and the control structures in this templating language to decide which jobs you want to create for the upgrade or for the initial install or delete or something like that. So that's not really easy to do all this with the Go or Helm templating language. It's much easier to use a real programming language.
Right. Which, it's arguable whether Ansible is that, but it'll at least be a start. Nate.
You had a whole bunch of things that were out of scope.
Yeah.
And so I'm wondering if maybe those things would have their own sub-operators eventually.
Well, I think that's kind of an interesting question. One thing that Helm is very well suited for example, is deploying a single sort of application like Okapi or Postgres, where that's not as complex. There aren't as many moving parts. There isn't part of what makes Folio operations so complex is that there's such a requirement for interaction with the Folio APIs as part of the provisioning. And while that will be simplified considerably by Eureka, it's not going away entirely. And so I think that's this is maybe a good place for Helm, is in some of this infrastructure deployment.
Yeah, that's kind of why I asked my question, went on a combo of both, right? For, let's say, a fresh instance, use Helm to put your platform there with all of those other out of scope things that the operator would not care about, right?
Right.
And once you have your cluster stayed with all of your infrastructure and a running system, now pop on the Folio operator.
Right.
Now we can do lifecycle management. Now we can do upgrades, backups, restore, tenant cloning, whatever you like.
Well,
whatever.
most of those are not in the original proof of concept.
But you can, because lifecycle management of Folio is also a difficult part of this.
It is.
Getting it running is one ginormous task, and then keeping it running is another ginormous series of tasks.
Well, and part of that management, so part of that management for us is because we use the GitOps methodology, that, this really did well with that. Because we're able to tag Git commits of this for the state of our cluster.
Yeah.
Right, and say, oh, well, actually, I need to roll the cluster back to this state,
Yeah.
or whatever. And so that's very powerful. And if there was also a way to reconcile Okapi or Folio to the state that I'm rolling back to, that would be really powerful as well. So.
And there also are operators for most of the big things, software that creates this.
Yeah, I certainly don't need to invent that. Yeah.
So I'll run a question.
Yeah.
Just as a outsider, you don't run anything. By implementing stuff like this, back in 2020, when I said at WOLFcon, that's quite a while ago.
Yep.
I asked community, I think, whether you were in that tech room, I remember at Texas A&M, there was a longer session of the day, and I asked, is there a standard way to deploy FOLIO? And everybody laughed. So I guess implementing this one, we have the options here. Are we moving to something closer to that? The reason why I ask that is because whilst there's a couple of big vendors running things, every now and then I with some smaller space that wants to, you guys don't follow, we are curious, we're interested. And I say, go check it out. And they see everything in their own way.
Sure.
And FOLIO is a really big beast, very hard to run and maintain. And I just wonder if the community at some point is going to think about the hosting companies or like small.
Think about us.
You know what I'm saying? You've got to think of as we move to something a bit more standardized and structured, because otherwise, like for example, you guys host it yourself, right? So I don't know how many staff you want to actually keep it running. Okay, That is so
I win the lottery.
yeah. So I'm just asking that as a general question because obviously,
No.
probably able to do
The operator will, in fact, remove the big first barrier.
Yeah, and that's a good question. That's a good point. And I think as the SysOps community, we've all kind of landed on one or the other, like single server, monolithic, or Kubernetes. And most people aren't doing anything much,
I don't think there's anyone in production trying to do this as a simple server.
Yeah.
I don't think so. I think as a community, we certainly have landed on Kubernetes, and it would be foolish not to build tooling
Yeah.
for that.
Sure.
But you've got a point. And I think that one way to make that more approachable is to start to do things like provide something like this where you could spin it up in microcades and install the operator and create something and, you know, start to see it. But it's a resource hog, and there's just not much you can do about that. I mean, like, the operations community can't at the moment do anything about that, you know, and yeah, that ends up being a development issue.
Sorry, just to add to that, because I think I ran operations at the National Library for a number of years.
Yeah.
I originally got my staff into lifting up and they all screamed at me, so hey, this thing sucks, so they walk over, thing back in the bin, so they tick that box, right?
Right.
But I think, to me, it feels like operations is the leftover or second cousin that gets forgotten. So the developers take first thing, create this thing with the gazillion trillion modules, like we discussed in the previous session. And I just wonder if it should be a bit more aligned, so we have a product that thinks a bit more about the life cycle and not just people migrating up, kind of stuff, so we can maintain it. And there can be further options than just a handful of vendors or et cetera. Because I think the community originally wanted their meaning, so we could be a bit more, but in truth, we're not really there.
So can I tell a parallel story? So I'm a developer, I don't do operations, I don't do backend, I don't do any of that stuff. And from some points of view, it would be really nice if we only develop stuff in a particular version of Java and in a particular version of JavaScript, because then there's a lot less stuff to support. But what we hear from institutions is it would be a lot easier to contribute if we could use the thing that we already use in our own system, because we have developers who know this and they contribute in Ruby, they can contribute in Perl, they can contribute in whatever. And so I've sort of seen the same thing from that. Like I view that problem that you're describing as sort of the same one from the operations point of view. It would be really nice if we could do this with Helm or with Kubernetes or with, I don't know your vocabulary, but I feel like it's the same thing, right? It's more efficient if we can centralize on a single thing. It works in a way, it allows us to do more things because we can all put all of our resources towards solving the problem in the same way. But that also ends up being more exclusive because people who don't necessarily want it solved that way for whatever reason sort of get left out.
Yeah.
So it's not that one of these is the right answer, it's that it's a challenge because the more things we try to support, the harder it is and the fewer resources we're able to bring to bear on any particular slice of the problem. So I've articulated it really well, but I think it's a hard reason for the community to agree on.
I don't disagree with you, but I think if you step back and see how many people serve post, 5, 10, or less, how many vendors are actually deploying it to the handful. What I'm trying to say is fundamentally, as an institution also may have the particular keynote on certain languages or frameworks. The fundamental truth is it's really 2 organizations with a couple of small players deploying it. So actually, I think we could actually stand up around it. Actually, it's not really necessarily relevant.
Would there be more players if there was more standardizations than all? Like, I don't know.
Well, I mean, so I just want to comment on that because I think that's really interesting. If a solution is attractive enough to the community to say, oh, well, okay, I could do this, or I could define 4 custom resources in a Kubernetes cluster. Maybe I better learn about Kubernetes.
Yeah,
you know, I mean, maybe that is, you know, like if it's attractive enough and it works, then maybe it drives in a non sort of, you know, kind of compulsory way to a better solution and the better technology, in my opinion, for for container management.
Even if there was one way to deploy Folio for a production environment, don't forget the way to deploy Folio for development is probably not that. I'm still that mythical guy who actually runs it on my laptop, you know, into the vagrant box.
It's a big laptop.
Right, yeah, it's got 64 gigs of RAM. You know, Olamide has, you know, been working on that busy bee to make that development, you know, roll out even more possible. No, I mean, I'm not an ops person, so Kubernetes looks great for people who know what they're doing, and it scares the hell out of me to try to imagine doing it locally, but being able to do vagrant, you know, up or whatever, like,
sure,
that's great. So maybe that there's even if we don't have a million different ways to deploy Folio, we need more than one. Because we need development places, and there's probably UI development versus backend development is probably two as well, and so, but I'm with you on commonalities and standardization to at least that we can.
And simplification, because maybe then it's cheaper to host it. All companies making money, but maybe it's still cheaper to, as a client who pays. I mean, it's just saying, you have all these flow-on effects, right? You've got to think of the entire thing. We want the thing to be sustainable in a way that these companies can still make their money and be happy and think of their shareholders or whatever that they're thinking of. So at the same time, as an institution is paying, I want to be able to have an affordable library management system where I can actually.
Not to forget, we raised the acceptance of FOLIO.
Yes.
And many more people can use it if it's simple.
Yeah. I did check, I was in a forum last year maybe, and there was like a random collection of extra customers. I don't know why I was there, I can't remember why. Anyway, there was this dude from India, okay, and he ran some academic institution, regardless, but after we had a long chat about running Folio in India, and his whole complaint to me was it's too expensive to run.
It's expensive.
Too expensive to run. He said, for that reason, there's no ways you could be deploying it to these smaller libraries, having smaller libraries. And I'm not saying we should solve it. It was a very interesting comment. I was like, with the programs, kind of things like that.
I will say one advantage that Kubernetes or microKs and all that has is you can actually turn that into a vagrant instrument.
Right.
And so like settling on a tech stack to manage the underlying infrastructure of Folio doesn't have to mean you have to run all of that. It means if you're used to Vagrant, I can turn that into a Vagrant box. It's like right now it's Docker, right?
Yes.
Under Vagrant that runs all the containers is Docker. Well, you can do that with Kubernetes also and distribute it, still distribute it through Vagrant or distribute it through Helm chart or distribute it, as a K3S or whatever you want to do.
Well, I mean, what we don't want to distribute is documentation that looks like this anymore. And I mean, Jason's written some of it. I've written a lot of it. It's hard to follow, and people look at it and go, well, I got lost at step 45. Sorry.
Yeah.
Right.
No, my documentation is horrible. I didn't get
Yeah. So we are at time. I don't want to keep people from lunch. I'm happy to stick around and chat if people want to chat. But thank you very much for your time and attention.